Good evening, students. Am I audible and visible? Just ping me the audibility and visibility in Flex. Very good evening. Okay. All clear from my side? Just ping me about the audibility and visibility. Is everything okay? Thank you, Kapil. So thank you. Very good evening again. Welcome to PW platform. Welcome to PW platform algorithm crash course. So we were discussing about dynamic programming last class. हमने dynamic programming देखा और problem of Fibonacci, elements of dynamic programming. Then we have also introduced to the concept of multi-stage graph. So today we will discuss the derivation of the recurrence based on optimal substructure property or based on principle of optimality for multi-stage graph, and then we will look into what is called LCS problem, longest common subsequence. Yeah, Nishu Kumar, thank you very much. Yeah, how to determine the minimum cost. So let's proceed with the today's agenda. Like this is the problem that we discussed yesterday. In short, I can represent the multi-stage graph phenomena like this. This is a starting node, that is the goal node. These are the first step options that are available to us, right? And these are the remaining path cost values. Greedy method, we said, is based on available step, available options, or at that step available option, greedily select that option which satisfies its objectivity. अगर ये problem हम greedy method से solve करते तो naturally we would have selected this option. Is it not? We would have gone to this node, and therefore the overall cost would have become 27. But rather than that, if I would have picked up this path, even though this 5 is more than 2, relatively the remaining cost of the path from this node to the goal node is 20, less than 25. So overall it is reducing the cost of 25. So that's the policy of multi-stage graph and other related problems. So चलिए start करते हैं same problem. This is my multi-stage graph as I mentioned in my last class. Once again I remind you, the graph is represented in the form of cost adjacency matrix. Again I am writing C1, 2, 3. It's a 12 cross 12 matrix. 1 to 1 there is no edge, 1 to 2 cost of the edge is 9, 1 to 2 cost of the edge is 1 to 3 cost of the edge is 7, like that. So here I write in short, Cij is edge cost. Okay. And we said we want path cost of the path from S to T. और हमने कल देखा उसका representation. I have shown you like this. Cost of Ij represents cost of the path from, notation काफी important है please, from vertex J that is in stage I. Vertex J is in stage I to reach the destination. Diagrammatically we said we want to go from vertex J, which is present in stage I, to reach the destination T. This is indicated by our formula cost of Ij. So kindly bear with me and try to understand that this is stage number, I is stage number and J is vertex in that stage. This is a point you have to understand. People often confuse and mix up I and J. I is stage number है, J is a vertex in that stage. जैसे मान लीजिए ये आपका first stage है, stage 1 vertex 1, this stage 2 vertex 2, 3, 4, 5, stage 3 vertex 6, 7, 8, stage 4 vertex 9, 10, 11, stage 12, stage 5 vertex 12. First and last stage will have only one vertex. तो जो अब हम ये जो formula derive करने वाले हैं cost of Ij, this is purely based on optimality structure property or principle of optimality. कैसे derive करेंगे? Please follow. It's a very simple and interesting approach of derivation, एंड प्रिडोमिनेंटली मोर और लेस हम यही प्रोसीजर फॉलो करेंगे ऑलमोस्ट ऑल अदर प्रॉब्लम्स के लिए भी। तो आप, मैं चाह रहा हूं कि इससे अच्छे तरीके से समझिए। या वेरी गुड इवनिंग अगेन टू ऑल ऑफ यू। वी वांट टू मिनिमाइज द कॉस्ट ऑफ द पाथ। देखिए हम फ्रॉम जे वी वांट टू गो टू एक्चुअली टी, हम वो कैसे ब्रेकअप करेंगे पाथ को फ्रॉम जे, राइट? अगर मतलब फॉर दिस ग्राफ, पहले ये ग्राफ के लिए हम बना लेंगे। फॉर दिस ग्राफ द इनिशियल वैल्यू ऑफ आई एंड जे आर 1 1, इज इट नॉट? The initial value of I and j for this graph is 1 and 1. First stage, first vertex, right? I want to minimize the cost of this path, so I would write like minimum of what? So from vertex 1, I should visit some vertex k. From 1, I should visit some vertex k, where I say k belong to a vertex present in second stage, and there must be an edge between 1 and k. 1 and k should belong to an edge. There must be an edge from 1 to k. And the cost of this edge is given by C of 1k. It's edge cost. From 1, I should visit some vertex k, having an edge between them, 1 and k, whose cost is 1k, such that the remaining cost of the remaining cost of the path from k to t is also minimum. Principle of optimality, optimal substructure यही बोलेगा कि जो remaining cost of the path होगा from k to t should also be minimum. Then only the overall cost from 1 to t will be minimum. ठीक है? तो अब ये पॉइंट है कि हाउ आर वी गोइंग टू राइट द कॉस्ट ऑफ द पाथ फ्रॉम के टू टी। रिमेनिंग सब पाथ का जो कॉस्ट है फ्रॉम के टू टी, हाउ विल यू राइट? प्लस रिकर्सिवली वी राइट इन टर्म्स ऑफ कॉस्ट। के इज प्रेजेंट इन सेकेंड स्टेज एंड वी से वी वांट टू बिगिन अवर पाथ फ्रॉम के ओनली, के टू टी, because cost of ij means cost of reaching destination t from j. Destination is by default t. I don't have to explicitly write the destination in the formula. हमें फॉर्मूला में डेस्टिनेशन टी लिखने की जरूरत नहीं है, तो जस्ट कॉस्ट ऑफ 2 कामा के। So minimize this. So on the right hand side I will write like C of 1 comma k plus cost of 2 comma k, where I say k belong to V2 and 1 comma k is an edge. So look at that, how we have broken the path into 2 subparts. One is edge, the other is subpath. Edge and subpath उसी तरह जैसा मेरे previous diagram में जो था, I have broken the path from start to goal. You can see I've broken my path from start to goal into 2 parts. This is edge and the remaining is subpath. So same way I have done here. Same way I have done here. Kindly see. So how do you generalize this? Now based on this, how do you generalize in terms of ij? Because later what happens is cost of first stage is measured in terms of second stage. Second stage will be measured in terms of third in terms of fourth. Like that it goes on. So therefore this should go in a generic way. Cost of ij will be nothing but minimum of C of j comma k. यहाँ पर generally students confuse हो जाते हैं. They try to write I. I is stage number please. J is vertex in that stage. So therefore we have to write j here. We have to write j here. Cost of the edge from j to some vertex k, where we would say k belong to next stage. So current stage is I, next stage will be I plus 1. I plus 1. Such that the remaining cost of the path from where to where now? From I plus 1, stage I plus 1 from vertex k. So this is a generalization of this equation. If you call this as equation 1, so this is a generalization of equation 1. So here this is I, this is j, this is j, this is k, this is I plus 1, this is k. That's what I wrote. And to complete that I would write j comma k must be an edge. That means from j I should visit only that vertex to which there is an edge. So this become my recurrence, dynamic programming based recurrence for solving this problem, and derived based on optimality principle. Principle of optimality के basis पर derive किया. Optimal substructure property is satisfied. Later by drawing the recursion tree we can show the overlapping subproblems also for this, right? So you can see cost of I is measured in terms of I plus 1, I plus 1 in terms of I plus 2, I plus 2 in terms of I plus 3. उसी तरह चलते जाएगा. How long should it go on? Or you can say that every recursion should have a boundary condition. आप ये recurrence को कैसे terminate करोगे? आप कैसे terminate करोगे? If you look at the graph, please observe. When I come to when the last but one stage, this is the last stage, Lth stage. Last but one is L minus 1. So when you come to L minus 1 stage, vertices that are present in L minus 1 stage, namely 9, 10, 11, they are connected to the destination directly by means of an edge. Again I repeat, vertices that are present in last but one stage is connected to destination directly by means of an edge, or edge cost is given by our matrix Cij. So therefore ये हम कैसे लिखेंगे, ये हम ऐसे लिखेंगे, cost of L minus 1, vertices present in L minus 1 stage, L is the number of stages, any vertex j will be nothing but C of j comma t, edge cost from j to t, j and t is edge cost, correct, right? So this will be your boundary condition. और अगर path construct करना हो आपको, then I will use another parameter called dij, another parameter called dij. Dij will give you the value of k that minimizes this equation 1, you can call this as equation 1, minimizes equation 1. Whichever k gives you minimum, that you are going to store in dij, which will help you in constructing the path. The formula cost will give you the cost value, d will give you the value which is minimizing for that. जैसे हम expand जब करेंगे तो we will try to get to it, we will understand that. Okay, we will understand that. अब कैसे solve करेंगे हम? So we can make a table, and I would be happy if you can fill up the values in that table. Let me see how many of you can work out. Let me see. I will make the table, and you are going to fill up the table like in tabulation process. Like in tabulation process. Okay? So here I will put the values. We'll have 3 entries here. I'll tell you what are these entries. This is vertices, this is the cost, and this is the d value. Okay? This is the tabulation process. So I'll say 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and I have 12. That's it. Is not needed. There are 12 vertices. Look at this, how we are going to fill up these values. First, I will explain to you what is the meaning of this table, so that I will give you 2-3 minutes of time, and let me see how many of you will be in a position to fill up this. How many of you will be in a position to fill up this? Okay? This is how you can be given a problem. This is how you can be given a problem in the exam, basically. Right? This is how the problem will be given in the exam. So please follow carefully. Yeah. K denotes the next vertex now. Yeah, exactly correct. First, let me explain what does this mean, and so that you can fill up, right? So you should have the practice. Tomorrow in the exam, problem may be described, values may be given, a table partial filling up the table may be given, and then you will be asked some question on the blanks. Yes? Yeah. What about Nishu Kumar? Why you are talking about substring? Substring की बात नहीं कर रहे हम यहाँ पर. हम अभी multi-stage graph में next problem is our substring. Look at this. So these are the vertices, the vertex 1. So this vertex 1 represent cost of reaching the destination 12 from vertex 1. This cost. And what is a via vertex? Like for example, if I am starting from 1, my via vertex can be 2, 3, 4, 5. When I come to 2, cost of reaching the destination t from vertex 2, via which vertex? Cost of 3, 4, 5 like. So always when I have tabulation process, like I can work in a bottom up fashion. I can work in a bottom up fashion. Right? This is not my memorization approach, this is a tabulation approach. So how do I work? So if I start from the last, cost of 12, there is no meaning in reaching from 12 to 12, right? There is no meaning in reaching from 12 to 12 because 12 is the destination t. So here I will put a dash, there is no meaning in cost, and then I will write it like 12 to 12 is direct link 12, or you can put dash also for that. Now when you come bottom up fashion, when you come to 11, look at that, 11 is here. So what is the cost of reaching from 11 to 12? There is a direct edge, so that belongs to your case, this case, equation 2. Cost of L minus 1 comma j, j is 11. Right, is equal to C of j comma t. What is the edge cost? 5. So therefore I can put 5. Via what? Direct link 12. Direct link we can put 12. Likewise, when you come to 10, cost of reaching from 10 to 12, that is nothing but again equation 2. So how much is the cost? 2, and direct link 12. When you come to 9, cost of reaching from 9 to 12, direct edge cost, because that is the boundary condition. So kitna hoga bhai? This is 4 and direct link 12. Right? Both easy hai. Now you tell me. Please fill up these remaining values and tell me, writing in the chat box, what will be cost of 8 and via value, cost of 7 via value, cost of 6 via value. Directly, without working also, orally by looking at the graph, that you can fill up this matrix. You can do that. That is what is the beauty of the problem. Come on, do it please. I will give you 2-3 minutes of time. Fill up the table. Fill up the table with the values. Come on, fill up. And tell me what is finally cost of 1. Let me see how many of you can give me the answer. What will be cost of 1? Cost of 1 is actually what is needed for us. हमें चाहिए cost of 1. उसके लिए हम build up करेंगे values from bottom to top. Fill up please. Tomorrow they may give a partial table like this and put some blank entries like PQR, and they will ask multiple choice question, what are the values of PQ and R? You have to follow. So if you know the procedure, you can do it. If you don't know the procedure, you will have to struggle. What is that 9 please, Anirudh Kulkarni? What is it 9? What is 9 representing? Can you elaborate, Aniruddha Kulkarni? What are you saying by 9? Yes, Tarandeep Singh, good evening. Cost of reaching 1 to 2 along the edge 9. No, it is not like that. Cost is equal to 16, path is 7, okay. Path is 7, you cannot say. Yeah, good evening to all of you once again. Come on, fill up the matrix please, fill up the table, tabulation process of multi-stage graph. Yes please, Nushu Kumar is right. Please don't spam, let us be very serious. कल ही हमने बात की थी about the career and this thing. So let us be serious about the class. Don't spam. Come on, we are seriously solving the problem. I want the values to be put in. Path is equal to 9. देखिए Anirudh Kulkarni, path cannot be 9. No, cost is 16, correct. Path का मतलब I want the total path. What is the total path of reaching from 1 to 12? You cannot write path is equal to 1 to. देखिए आप, I'm trying to continue to fill up this. What is cost of 8? Cost of 8, vertex 8. पहले हम understand करेंगे meaning क्या है cost of 8 का. Cost of 8 means cost of reaching the destination vertex T, cost of reaching the destination vertex T from 8 present in third stage. अगर आप फॉर्मूला के बेसिस पे जाएंगे, मैं थोड़ा इसे रब कर लूंगा अब क्योंकि आप लोग को समझ में आ गया, आई विल रिमूव दिस सो दैट आई कैन राइट डाउन एवरीथिंग एट वन प्लेस. ठीक है, देखिए cost of vertex 3 in short actually cost of vertex 8 in short actually means cost of 3 8, because where is 8 present? 8 is present in stage 3. So what is cost of 3 8? Actually you can expand by formula. एक्चुअली होना चाहिए, आप एक्सपैंड करेंगे फॉर्मूला के बेसिस पे, लेकिन आप गेट एग्जाम में फॉर्मूला के बेसिस पे एक्सपैंड करोगे, राइट, देन यू विल हैव टू वेस्ट अ लॉट ऑफ टाइम. तो मैं ये चाहूंगा कि आप शॉर्टकट मेथड अप्लाइड कीजिए, विच आई एम गोइंग टू शो इट नाउ फॉर by putting the values here. कैसे करेंगे शॉर्टकट मेथड? प्लीज ऑब्जर्व, यू कैन चेक डायरेक्टली फ्रॉम 8 देयर आर 2 पार्ट्स, 8 10 12, 8 11 12. इसका कॉस्ट कितना है? 5 प्लस, हमने 10 की वैल्यू ऑलरेडी कंप्यूट की थी 2, 5 प्लस 2 7, 6, दिस इज 6. 6 plus, we have already computed 11, 5, 11, right? 6 plus 5, 11. So 5 plus 2, 7 is minimum. So I'll write it like 7 here. 7. Going via which path is, which vertex is giving you minimum? Going via 10 is giving you minimum. So write 10. Write 10. Got it? और एक कर लेंगे. What is cost of 7? मतलब where is 7 present? Third stage. Cost of 3, 7. देखिए आप दो options है. 7, 9, 12. 7, 9, 12. It is having a cost value of 4 plus 4. और एक है option 7, 10, 12. This is having cost value 3 plus 2. So this is 5. Going via 10 is giving you minimum. So write down 10. Very simple. अगर आप समझ गए तो hardly within seconds you can fill up this matrix. Fill up this matrix within seconds. Is it not? अब उसके बाद आ जाइए cost of 3, 6. दो options है 6 plus 4, 5 plus 2. So obviously 5 plus 2 is minimum 7 via 10. So all are 10. अब देखेंगे हम, right? अब हो गए, अब करेंगे हम cost of now 5. Where is 5? 5 is present in second stage. Please observe. 5 is present in second stage. So cost of 2, 5. There are two options. This is 8 and this is 11. So 11 plus 7. 11 plus 7 का cost कितना है? 5. 11 plus 5, 16. इसका कितना है? 8 plus 8. 8 का cost है 7, 15. 8 plus 7 is 15. So 16 and 15. 15 is minimum. Please correct me if I am wrong at any place. This going via 8 is giving you minimum. Check me if I am making any mistake, because sometime I can also make a simple silly mistake. अब उसके बाद क्या होगा? Cost of 4. मतलब देखिए यहाँ पे तो एक ही ऑप्शन है आपके पास. 11 plus cost of 8. Cost of 8 is 7. So 11 plus 7, 18. Where there is no option other than 8. So we write 8. देखिए आप कितना फास्ट हम फिलअप कर सक रहे हैं. यहाँ पे फिर भी मैं आपको एक्सप्लेन कर रहा हूँ. अगर एक्सप्लेन ना करूँ तो हार्डली 20 सेकेंड्स में फिलअप कर दूंगा मैं मैट्रिक्स. कोई भी मैट्रिक्स आई कैन चैलेंज यू. 20 minutes, 20 seconds I can fill up it. And I can solve this problem in less than half minute. If you practice. So that is the beauty of shortcuts of dynamic programming. Okay. Then when you come to 3, there are two options. 2 plus 6, 2 plus 7, 9. The other option is 7 plus 7, 7 plus 5, 12. So therefore 9 is better. So I will put 9 for 3. Right? Going via 6 is minimum. Then 2, 2. This is the fun. Right? So I have three options. 4 plus 7, 11. 2 plus 7, 2 plus 7, 7. And the other is 1 plus 8. 1 plus 8 is 8. So therefore I think this is minimum. 2 plus 7. 2 plus 7 is 5. 2 plus 5. 7 is minimum. 2 plus 5. Cost of 7. 2 plus 5. 7 is minimum. Going via 7. That's all. That's all is the concept if you observe. Right? Tabulation approach is quite fast. As Anuruddha is also saying. Very fast. That's what I said. Within 15-20 seconds, if you are in practice, you can fill up this. And you can easily construct the path also. So therefore, questions like this with tabulation you can solve. Finally, I come to 1. 9 plus 2 means 9 plus 7, 16. 7 plus 9, 16. 3 plus 4, 21. 2 plus 5, 17. So minimum is 16. 9 plus 7 or 7 plus 9. So I'll put 16. And this is possible going via 2 or via 3. You can put two values if you want, via 2 or via 3. That's all. My problem is, so I got the minimum cost path. So therefore, as per the matrix, the minimum cost is 16. But we have to verify how we got 16. Right? What is the path? How are we going to construct the path? Construction of the path is also very simple. Can anybody tell me, writing down in the chat box, how do you construct the path? Come on, boys and girls. How do you construct the path? Anybody? We can construct the path by using the values of D. That is also a very interesting approach. We can construct the path by using the values of D's. These are here. The purpose of monitoring the values of D's are to construct the path. लेकिन ये values of D use करते हुए हम कैसे path construct करेंगे? चलिए start करेंगे. Please observe here. How am I constructing? It's very interesting, right? My path will start from vertex 1. Which vertex are we visiting from vertex 1 is given by vertex 1 present in stage 1. This stage 1, vertex 1. What is this value? D11. This stage 1, vertex 1. This value is either 2 or 3. You can take anything. Let's say I am taking 2. So that means from 1 I am going to 2. Now to find out what is the next vertex that we are visiting, I have to look into now second stage. First stage is over. Now second stage, which vertex are we visiting? 2. So I have to look into d of 2, 2. d of 2, 2 means this value 2. What is this value? 7. Look at this. This value is 7. So that means I am going to 7. From 2 I am going to 7. From 2 I am going to 7. ठीक है? फिर उसके बाद क्या होगा? Now from 7 which vertex I am supposed to visit? So I have 7. Where is 7 present? Third stage. So I have to look into the parameter d of 3, 7. d of 3, 7 means 7. d of 3, 7. Look at this. Look at this. This stage number, vertex number. Stage number, vertex number. Vertex number is 7. So therefore, what is that value? 10. So we are visiting 10. Right? The moment I come to 10, look at the graph. The moment I come to 10, there is no option other than going to 12. हम यहाँ पर stop कर सकते हैं. Directly I can write 12. Even if you don't want, you can write next stage d of 4, 10. That will be 12. You can check it 12. So therefore, this is my path. It has two paths. I have constructed one of them, right? This path is 1, 2, 7, 10, 12. इस तरह से है. This is the path. There is one more path. अगर आप d11 की वैल्यू 2 भी ले सकते हो और 3 भी ले सकते हो. अगर हम 3 लेंगे तो I get another path. d of 3 will be 6. So मतलब you will go like 1, 3, 6, 10, 12. 1, 3, 6, 10, 12. Exactly correct. Rahatullah Ansari. So that is the beauty of the multi-stage graph. Right? So that is the how we can solve this problem using optimality principle. यहाँ पर दो चीजें important है. Number one, you should observe that the problem has optimal substructure property and you can also see that it has overlapping subproblem. दो चीजें हैं. तो जैसे ही आप prove करोगे कि it has optimal substructure property, using that optimality principle you should derive this formula. ये बहुत important है. ये formula derivation बहुत important है. Every problem of dynamic programming, we represent its solution, we derive its solution by applying optimal substructure or optimality principle like this. इस तरीके का formula. ये formula derive करने के बाद you can follow either tabulation process or you can follow memoization process. मैंने tabulation किया because tabulation is most often very simple. Bottom up approach is always desirable for solving problems. Right? So this is the bottom up approach which I have just now demonstrated how we have filled up this table. That's it. This is multi-stage graph. ठीक है? चलिए अब next problem लेंगे. आज का agenda जो था longest common subsequence. So let me write it here. Longest common subsequence. LCS. It's a problem related to strings. राइट अगर आप चाहें एज अ मैटर ऑफ फर्दर कोडिंग एक्सरसाइज आप ये भी कर सकते हो. डायनेमिक प्रोग्रामिंग का जो हमने इक्वेशन डिराइव किया वो बेसिस पर उसको आप मेमोराइजेशन फॉर्म में भी कर सकते हो और फिर आप एक प्रोग्राम भी लिख सकते हो. राइट इन C++ और जावा कन्वर्टिंग द एल्गोरिथम इनटू प्रोग्राम. दैट विल बी इंटरेस्टिंग कोडिंग एक्सरसाइज बट आई वुड सजेस्ट डोंट डू इट नाउ फ्रॉम एग्जामिनेशन परस्पेक्टिव. गेट एग्जाम परस्पेक्टिव से आपको कोडिंग इंपॉर्टेंट नहीं है. आफ्टर गेट एग्जाम इज ओवर मेरी लास्ट क्लास ऑफ एल्गोरिथम में आई विल टेल यू what to do with regard to coding after the GATE exam is over. How you should do coding, what you should do, that we will discuss later. So this is one aspect which you can codify after the examination, not now. Okay? So that will be interesting exercise. चलिए, longest common subsequence. It's a problem related to string related problem. So I don't have to define what is a string. Everybody is knowledgeable. Everybody is aware of what is a string. String is a group of one or more characters, including the null character. Like for example, if you talk about C, लेकिन generally जब हम बात करेंगे तो null character की बात नहीं करेंगे. Let us say the string is a group of one or more characters. Group of one or more characters. तो हर string के लिए there are two things which need to understand. One is called substring. Like for example, this is an example of a string. Every string may have something called substring and subsequence. ये हमें पहले अंडरस्टैंड करना है. देन वी विल अंडरस्टैंड व्हाट इज कॉमन सबसीक्वेंस. फिर और हम देखेंगे व्हाट इज लॉन्गेस्ट कॉमन सबसीक्वेंस. ठीक है? तो व्हाट इज सबस्ट्रिंग एंड सबसीक्वेंस. क्या आप कोई लिख के बताओगे मुझे व्हाट इज सबस्ट्रिंग एंड व्हाट इज अ सबसीक्वेंस? कम ऑन बॉयज एंड गर्ल्स. व्हाट इज अ सबस्ट्रिंग एंड व्हाट इज अ सबसीक्वेंस? एनी रिस्पॉन्सेस? Come on, Vivekanand, Shifu Qadir, Nishu Kumar, logical learner. What is a substring and what is a subsequence, or what is the difference between them? Any idea, any knowledge? Group of characters with repetitive characters. Anirudh Kulkarni. Okay. Repetitive characters का मतलब क्या है? Generally people get confused between substring and subsequence. That is why I am asking, what is a substring and what is a subsequence? Are they same or different? Are they same or different? Okay, subsequent, any group of characters with unique characters. See, uniqueness is always there. I cannot have a repetition of the character. Yeah, it is different, but what is the fundamental difference between substring and a subsequence? Yes, Diksha Tripathi has told clearly, substring is it obeys the property of contiguity, continuous, but subsequence need not be contiguous. Need not be contiguous. Let me write the definition. Group of one or more contiguous characters taken in a sequence is substring, is a substring. What is a subsequence? Group of one or more characters that need not be, this is important, that need not be contiguous. Nevertheless, must be taken in order. Must be taken in order. This is the definition of subsequence. Contiguous होना जरूरी नहीं है subsequence में, लेकिन order maintain होना जरूरी है. Order, जिस order में characters string में है, उसी order में subsequence में भी आएंगे. Order is important in both substring as well as subsequence. लेकिन fundamental difference between substring and subsequence is that substring need not be substring is always contiguous. Subsequence need not be contiguous, but nevertheless, nevertheless का मतलब like in, order should be maintained. Order of the character must be maintained. That is nothing but subsequence. So this implies that every substring is a subsequence, but every subsequence is not a substring. Again I repeat, every substring is a subsequence, but every subsequence is not a substring, क्योंकि वहाँ पर contiguity constraint नहीं है. जैसा for example, if this is the string given to us, this is a string given to us, what are some of the substrings of this? What are some of the substrings of this? Like for example, you can directly take from A, from here CGA, or you can in between also you can take like GATA, right? Or in between again you can have A double T G, something like these are all substrings. But for example, if you take like A, this is not a subsequence, substring. This is not a substring. Why? Contiguity is not there. I am taking perhaps this A double A, right? And then maybe another A here. So therefore this cannot be. I don't have 4 contiguous A, that is what I am saying. I don't have 4 contiguous A. So therefore this is not a substring, right? But when I come to subsequence, all these what I have written earlier are subsequences also. Like whatever I have written earlier, that I am marking it, are subsequences also. Are subsequences. And in fact 4 A's is also a subsequence. Is also a subsequence, because this A, and then I take this A, possible. Like that I can have other subsequence. I can say triple T GA is also a subsequence. Look at that, triple T. I am taking this T, double T, and then G. You can take this G, or you can take GA, or you can take these two GA. This is subsequence. So like that, these are the examples of subsequence. In respect of this substring, in respect of this string, मैं एक यहाँ पर subsequence लेने की कोशिश कर रहा हूँ. आप बताइए, is it a valid subsequence or not? Like I write A, T, A, T, T. Come on, tell me. Is this a valid subsequence of the given string or not? Come on, answer me. Last का एक बार मुझे बता दीजिए. Is this, because यहाँ पर जनरली एक स्टूडेंट को कंफ्यूजन होता है, इसलिए मैं क्लैरिफाई करना चाह रहा हूँ. Is this a valid subsequence of this string or not? No. Is this a valid substring? No, it is not. Yes. Why? Why is it not? Some people have a doubt. Why is it not? Because after reaching end, you cannot go back and continue. It is not like a circular queue, please, just as some people may assume. Order is not maintained. It is not like a circular queue. Some student would say, sir, I will take this A, then G, then A. After that, I will go back like a circular queue and take C from here and then T. No, 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 no. You cannot take a circular queue. You cannot assume the string like a circular queue and take. Okay? So therefore, this is not a valid subsequence. Hope the point is clear. इससे पहले हम आगे बढ़े, एक सिंपल क्वेश्चन मैं पूछ लूंगा. Let me see how many of you can answer me. For a given string of length n characters, please answer. For a given string of length n characters, like imagine this is having n characters. Can you tell me how many substrings are possible and how many subsequences are possible? Order of dash and order of dash. This is an important point. What do you mean by GF? Rajat Kumar. Please see here. Concentrate here. There are some elements which are to be ignored. So please observe here. How to get a substring here? I mean, how many substrings are possible for a given string? Come on. How many substrings are possible for a given string? Come on, tell me please. How many substrings are possible for a given string having length n characters? Answer me. Prashant Kumar, n square. Kushal Yadav is saying very clear, order of n square. How? Very simple. हम एक छोटा एग्जाम्पल ले लेंगे यहाँ पर. छोटा एग्जाम्पल ले लेंगे. Please observe. Suppose if my string is having characters A, B, C. पहले हम substring की बात कर लेंगे. I will have three substrings of length 1 characters. 3 substrings. Number of substrings with 2 characters A, B, B, C, and 1 substring with all 3 characters 1, right? So therefore total number of strings are 1 plus 2 plus 3 for a length of 3. If I have length 4, then it is 1 plus 2 plus 3 plus 4, right? If I have length n, then it will be n into roughly n plus 1 by 2. If you take the order, will become order of n square. Will become order of n square this way. N into n plus 1 by 2 plus 1 you are adding for null character, right? I believe that null string, so that's why I'm ignoring null string here. So therefore order of n square. हाँ, लेकिन आप subsequences की बात करोगे, maybe if you cannot justify because the length of 3 will become a very small for subsequences, but there will be 3 for subsequences also, and then this will be 3, is it not? This will be 3 for subsequences. I will have another subsequence like AC. In addition to AB and BC, I will have another subsequence of AC and then ABC like that. So therefore, if you take more characters, like if you take 4 and 5 characters, then you can prove that to be order of 2 power n. This is an important conclusion. Order of 2 power n. Order of 2 power n. So remember this as an important formula. The number of substrings possible for a given string of length n characters is n square, order of n square, and the number of subsequences are order of 2 power n exponential. 2 power n subsequences are possible for a given string of length n characters. चलिए आगे बढ़ेंगे और देखेंगे कि what is the concept of common subsequence. Very simple. जब बात होगी common subsequence की तो we should be given 2 or more strings. So therefore given 2 strings x and y, something like this. A subsequence that is common to both x and y. A subsequence that is common to both x and y is called common subsequence. So just for example, for this I can say BCB. Is it a valid subsequence of both x and y? BCB is a valid subsequence of both x and y. Yes, it is a common. देखिए आप यहाँ पर है BCB and then I can take BCB. So therefore it is a common subsequence. और हम बोलेंगे इसकी length है 3 characters. उसी तरह for example I can say BCBA. BCBA. Is it a common subsequence? BCBA. BCBA. Yes, this is also a common subsequence of length 4. उसी तरह length 2 के भी होंगे. Can I have BD? Yes, this is of length 2. Can I have a common subsequence of length more than 4? Come on, answer me, boys and girls. Let me see. Can I have a common subsequence of both x and y of length 5? लेंथ 4 की तो हमने की, लेंथ 5 की क्या है? डू वी हैव ए कॉमन सबसीक्वेंस ऑफ लेंथ 5 फॉर बोथ x and y? कम ऑन, do we have a length of common subsequence of length 5? No, I don't have. I don't have. You can check it. If you start with ABC, I don't have ABC, right? If you start with BC, yes, I can have BC, BA. BC, BA, B is there, but BC, BA, B is not there. So therefore, the maximum common subsequence is of length 4 for these two strings x and y. The maximum possible is 4 for this, right? And that is what is called longest common subsequence. राइट? सो हमने डिफाइन किया पहले व्हाट इज सबसीक्वेंस, फिर हमने बात की कॉमन सबसीक्वेंस की, और उसके बाद अमंग ऑल द सबसीक्वेंस विच एवर सबसीक्वेंस इज हैविंग द लॉन्गेस्ट लेंथ, दैट इज कॉल्ड लॉन्गेस्ट कॉमन सबसीक्वेंस. तो मतलब आपका प्रॉब्लम डेफिनेशन हो जाएगा इस तरीके से. हम लिखेंगे प्रॉब्लम डेफिनेशन को, गिवन टू स्ट्रिंग्स x and y of length, some length you can assume, n and m characters, the problem of LCS is to determine a common subsequence of x and y of longest length. ये है problem definition. Longest length. This is the problem definition of LCS. Given the two strings x and y of longest of length n and m characters, we want to find a common subsequence of both x and y of longest length. इससे पहले हम देखें कि हम इसका डेरिवेशन कैसे करेंगे, प्रॉब्लम कैसे सॉल्व करेंगे, टैबुलेशन मेथड से, राइट, और रिकर्शन ट्री अप्रोच से. इससे पहले वो देखें, वी विल क्विकली हैव अ लुक एट सम ऑफ द इम्पॉर्टेंट, क्योंकि आपको पता होना चाहिए कि इसके प्रैक्टिकल एस्पेक्ट्स क्या है, प्रैक्टिकल एप्लीकेशंस आर इम्पॉर्टेंट. जैसे मैंने कहा, मल्टी स्टेज ग्राफ के यू हैव practical applications in civil and mechanical engineering to work out the problem that are related to flow of fluid, flow of gaseous in pipelines. So pipelines के उनके जो problems होते हैं that are based on multi-stage graph. Yes, you can have many substrings of length 4. Why not? BCBA is there and there. BDBA is also there. You can have multiple subsequences of longest length. Why not? ठीक है. चलिए मुझे कोई बताइए लिख के, what do you think are the important prominent applications of common subsequence LCS problem? Some of the important applications of LCS. क्या आप लिख के बताओगे? What are the important applications? Where do we use this problem? It's a problem which is very popularly used. Yes, somebody has written already. Anirudh has written network routing, not network routing. नेटवर्क रूटिंग में आप यू विल यूज स्पैनिंग ट्री बेस्ड एल्गोरिथम, मिनिमम कॉस्ट स्पैनिंग ट्री है, राइट, फॉर अचीविंग ए मल्टीकास्टिंग. इट्स एन ऑप्टिमाइजेशन प्रॉब्लम. ट्रू, दिस प्रॉब्लम इज एन ऑप्टिमाइजेशन प्रॉब्लम. बट नाउ आई एम नॉट आस्किंग दैट. आई एम आस्किंग यू, व्हाट आर द एप्लीकेशंस ऑफ LCS? Yes, many people have written. Number one, it is used in genomics, genetic engineering. I will talk about it. I will explain to you so that you remember, conceptualize. Secondly, it is used in plagiarism of software. It is used in basically like open source software testing. Open source softwares. Plagiarism, again, it is the same concept, right? Yeah, search engine, it is also used in search. Most of our Google search, etc., they adopt this. जैसे कि आप Google में एड्रेस बार में, if you start typing, right, what is so and so, then it start giving you the suggestions, is it not? So that is nothing but LCS problem. सबसे पहले हम डिस्कस करेंगे जीनोमिक्स का, जेनेटिक इंजीनियरिंग में. तो जनरली द बायोलॉजिस्ट जो है, वो जो genetic engineering में they test the genes of people, right? That comes in the form of what is called a code word, which is represented in the form of a string like this, right? The code word which comes of a genetic structure comes in the form of a code word. So I want to know there are two people, for example, P1 and P2. Right? I got the one code word of one person. I got another code word of another person. They generally, the biologists, they call these code words are strand. उनकी terminology में वो बोलते हैं strand. So what they do is they say that the genetic structure of both these people would be same if they have a common subsequence of at least lambda, some lambda. They say that okay, अगर दोनों strand is nothing but a string, तो दोनों का अगर common subsequence has a length of at least lambda, they come to a conclusion that these two people have the same genetic structure. मतलब शायद ये father हो या son हो, something like that, genetic structure. So this is used in basically for genetic structure to find out whether both of them belong to the same genetic structure or not. Like that, plagiarism. Plagiarism is basically, it can be used by researchers, it can be used by software developers to know whether the content that they have developed is an original one or not. Generally क्या होता है, when people carry out the research, right, when they write the research papers, they copy the content from other people and they say that it is my own. और जब वो copy करते हैं, they do intelligent copy. It is not like just cut and copy. They will try to modify the sentence. कुछ words add करते हैं बीच में, कुछ word delete करते हैं, so that they say that this is their original content. Generally, yes, PhD scholars, PhD researchers, they do this. So to test that, we have this plagiarism software, जो purely LCS problem के basis पर work करता है. जैसा एक example दे रहा हूं मैं समझने के लिए, अगर मान लीजिए कि एक सेंटेंस है, रवि एट एप्पल, एक सेंटेंस है एक पेपर में, उसको एक रिसर्चर ने ऐसा लिखा, एप्पल वाज ईटन बाय रवि, और वो बोलेगा कि ये मेरा सेंटेंस है, हालांकि उसने सेंटेंस को मॉडिफाई कर दिया है, राइट, लेकिन मीनिंग तो सेम है. तो बोलेगा कि नहीं, दिस इज माय इन्वेंशन, दिस इज माय डिस्कवरी. It is not his invention, his discovery. The LCS problem can catch such sentences and say that this is not basically like the original content. So that is the meaning of plagiarism. ओपन सोर्स सॉफ्टवेयर भी उसी तरह है. आपने ओपन सोर्स सॉफ्टवेयर डाउनलोड किया, उसमें कुछ चेंजेस किया और आप बोलेंगे कि ये मेरा सॉफ्टवेयर है. So we can basically test whether they belong to the same thing or not. उसी तरह based on working of this in Unix particularly, we have a command called diff. I don't know, some of you who are Unix users, Linux users, there is a command called diff, D-I-F-F, diff, to check the difference of two files. Right? To check the difference of two files. So that is the command. Diff is basically implemented using LCS problem. Then finally, search engine, जैसे मैंने कहा भी, so that is also based on implementation with LCS problem. So my dear students, yeah, diff stands for difference. Difference between two files. I want to know how far are the two files, given two files, different in respect of that. Yeah. So code comparators, differentiators, these are all implemented based on the ideology of LCS problem. So I'm just trying to say that essentially LCS problem is a practical in-use problem. So therefore, we should have a mechanism to find all such things, correct? So now the question is, how are we going? So this is my problem statement, please. Given two strings x and y, having length n and m respectively, we want to find common subsequence of longest length. So how do we do that? So let us build up some ideology here, some terms. I have taken two strings, for example. So first I will put the case like this. Let x, the string x, I will write it like this, x1, x2, so on, n characters. Like, let us assign indices to these characters starting from 1, 2, going up to n. And like that, here we take the string y. I'm making a derivation of the recurrence. Later I will show you that it satisfies, it satisfies both the properties. I will show you that it satisfies common subproblem, overlapping subproblems, and also the optimal substructure property will prove it, don't worry, right? So y is equal to, let us say characters are y1, y2, y3, so on, ym. So string x of length n characters, string y of length y characters. So here we mark 1, 2, 3, so on, some m. Right? I am starting the index from 1 and starting the index from m. So here we will say, let L of n comma m represent the length of common subsequence length of common subsequence of the two strings x having n characters and y having m characters. So now the question is, how are we going to derive the formula for L of n comma m? This can be done in two cases. See, what is the basic operation or the basic metric that we are using for finding the value of L of ij or L of n comma m? What should be the metric here? Come on. What is the basic operation, primitive operation? Which operation are we going to deploy here for finding the common subsequence? Come on, boys and girls. What is the basic operation? No, not index. Operation जैसा कि आप addition, multiplication, comparison, etc. Which basic operation are we going to use? Character matching, comparison. That's what I was saying. Comparison. देखिए आप. So basically, if I assign numbering to this, I will call this as 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And this, if I assign numbering down, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So this string has 12 characters, this string has 10 characters. So first comparison, I mean, I can make comparison from the first character, I can make the comparison from the last character. Making the comparison from last character becomes easy for me to make a derivation. Becomes easy for me to make a derivation. ठीक है? तो देखिए आप last character, case 1, this is case 1. Case 1 में ऐसा होगा कि last character of both the string will match. Last character of both the string will match. जैसे यहाँ पर देखिए आप both of them are matching. जब both of them are matching, definitely, so this is my case 1 derivation. Case 1 derivation. When both the last character of both the strings are matching, then definitely I can say that my common subsequence will end with this character A. Definitely it will end with this character A. इसका मतलब ये है कि मेरी minimum common subsequence की length 1 है. Right? Minimum length of the common subsequence is 1 minimum. Definitely for sure. ठीक है? So therefore I would write like 1 plus, when, what is case 1? Case 1 is the last character x of n is matching with y of m. X of n matching with y of m. So 1 plus what? Come on. What should I write? 1 plus whatever is the length of common subsequence of, based on optimal substructure property, whatever is the length of common subsequence of, right? Whatever is the length of common subsequence of the remaining characters of x and remaining characters of y. तो हम कैसे लिखेंगे recursively remaining characters of x and y? Come on, boys and girls, tell me, how do we write? So L of nm is equal to 1 plus both of the last character. This is my n, this is my m. So both of them have matched. So it is 1, length of the common subsequence is 1. 1 plus whatever is the remaining characters of string x and y. So therefore we will write like L of n minus 1 comma m minus 1. That's all. This case 1. Case 1 is very simple. If there is a match, then again I will match n minus 1 and m. They are not matching. When they are not matching, then case 2 will arise. Case 2. Case 2 will arise. So in case 2, what shall we write? L of n comma m is equal to, look at this, last characters are not matching. A and G are not matching. They are not matching. So when they are not matching, then that means the length of common subsequence, right, or the common subsequence may end with A, last character of x, or may end with G, last character of y, or may not end with both, right? So may end with A, may end with G, or may not end with either of them. In our example, for instance, if you observe, it is ending with last character of x, because this character A is matching with the last character of x, so it is ending like this. Sometime it may happen it will end with J and not ending with A. So that is the meaning of it. So in that case, what we do is, we are going to basically compare the whole x with one character less of y, or I will compare y whole with one character less of x. So whichever of these two give me maximum of these two cases, ending with x, not with y, ending with y, not with x, whichever is maximum out of these two, that I will take it as length of common subsequence. So that I can write recursively as what? Maximum of, come on boys and girls, L of ending with x, not with y. So I will write like L of n comma m minus 1 and L of n minus 1 comma m. That's it. Maximum of this. This will be the formula when for case 2. So what is case 2? It is not matching. X of n is not equal to y of m. This will be the case. This will be the case. That's all. This is optimal substructure property. L is computed again in terms of L. L is computed again in terms of L. L is computed again in terms of L, right? With less number of characters. The string less coming out. So therefore optimal substructure property is very well satisfied. और हम एक रिकर्शन ट्री ड्रॉ करके ये भी बता देंगे कि कैसे दिस इज गोइंग टू ओबे और सैटिस्फाई ओवरलैपिंग सब प्रॉब्लम्स, हाउ ओवरलैपिंग सब प्रॉब्लम्स आर आल्सो हैपनिंग हियर. That is also possible, right? Maximum of this and right. Yeah, Nishu Kumar, you are talking about the table. We'll come to that. We'll come to that table, right? But first we'll build up the understanding with regard to the derivation of the recurrence. लेकिन चूंकि recurrence है, recurrence always we have been telling, please observe, we have been always telling that recurrence should have boundary condition. क्या कोई मुझे लिखकर बता देगा इस chat window में how are we going to terminate the recurrence for case 1 and case 2? Come on. How are we going to terminate the recurrence for case 1 and case 2? How are we going to terminate the recurrence of case 1 and case 2? Can you please write down and tell? Terminating condition कैसे होगा? Generally मैं ये कहता हूँ कि students को when you are preparing for GATE, dynamic programming में terminating condition can also be asked as one mark question. तो इसका terminating condition बता दीजिए मुझे यहाँ पर लिख के. How are we going to terminate this? Come on. How are we going to terminate this? Anybody? What should be the terminating condition? Let us write it here. If length of one string becomes 0, yes, one string get exhausted, or the other get exhausted, or both get exhausted, then the length of common subsequence becomes 0. So therefore I will write it like for example, L of ij is equal to 0 for I is equal to 0, j is equal to 0, or j is equal to 0. Is it not? Or if you want, I can write it like this. L of if I is 0 and any value of j here, any value of j is 0, right? J can be either 0, 1, 2, anything. Or L of I comma 0, next parameter is 0. That means second string is 0, is also 0 for I is equal to 0, 1, 2, any number of characters. This become my boundary condition. This become my boundary condition. Right? So this is how I can draft the equation for LCS problem. Based on this equation, very quickly I will try to show, how it obey or satisfy the condition of overlapping subproblem. Please see, very simple. Basically, when I work for n comma m recursively, see there are 3 subproblems which I have to solve. Check it. I'm calling it, okay, I'll write LCS only. LCS of n comma m. First is I can solve n minus 1 comma m minus 1. Is it not? Or I can solve LCS of n comma m minus 1, or I can solve LCS of n minus 1 comma m minus 1. Sorry, m. Check it. Am I supposed to take maximum of these two? Of these two subproblems? First level of recursion? You can take minus 1 if you start the indexing from 0. That all depends on how you are indexing. Shifu Khadir. If you are indexing from 1, then 0 become the condition. If you are indexing from 0, then it become minus 1. That's matter of only how you are representing. Now boys and girls, अगर आप इसे expand करोगे, again it will have 3 subproblems. क्या होगे? LCS of n minus 2 m minus 2, या LCS of n minus 1 comma m minus 2, या LCS of n minus 2 m minus 1. Is it not? Check it. हाँ, अगर ये आप expand करोगे, मैं यहां पर लेके expand कर रहा हूं, 3 सब प्रॉब्लम्स इसके ऐसे होंगे. LCS of n minus 1 m minus 2, or LCS of n comma m minus 2, or LCS of n minus 1 m minus 1. Hope you are able to understand the derivation of this recursion tree. अगर आप इसे expand करोगे, I will have three sub problems which I am writing it here. LCS of n minus 1, sorry, n minus 2, n minus 2, m minus 1, or LCS of n minus 2, sorry, n minus 1, m minus 1, or LCS of n minus 2 comma m. देख लीजिए एक बार, समझ में आ गया डेरिवेशन ऑफ द ट्री. अब यहीं पर हम बता देंगे वेयर आर द ओवरलैपिंग सब प्रॉब्लम्स. कम ऑन, कहां पर है ओवरलैपिंग सब प्रॉब्लम्स? देखिए आप, यहां पर लेफ्ट में ले रहा हूं मैं, LCS ऑफ n minus 2 m minus 2, n minus 2 m minus 2. यहां पे ये छोड़ देंगे हम, इसको ले लीजिए, यहां पर है, बिकॉज दिस विल कम एट लेटर पॉइंट ऑफ टाइम. दिस LCS ऑफ n minus 1 m minus 2, n minus 1 m minus 2. देखिए अब यहां पर रिपीट हो रहा है ओवरलैपिंग सब प्रॉब्लम्स, राइट? And likewise again you will have n minus 2 m minus 1 somewhere, n minus 2 m minus 1. I will show with another ink so that you can have understanding. Another set of overlapping sub problems. और एक भी set of overlapping sub problem बता दूं मैं आपको. LCS of n minus 1 m minus 1, LCS of n minus 1 m minus 1. Look at this. 3 different colors से मैं आपको बता दे रहा हूं. This is directly the expansion of it. ये जो formula है शिफू खादिर, please observe. This is a formula ना, maximum of n comma m minus 1, n comma m minus 1, terminating with x but not with y, terminating with y but not with x. ये formula use किया मैं यहाँ पर. I have used this formula here. Please check. This is case 2. Case 2. LCS of n comma m minus 1 or n minus 1 comma m. I hope it is clear. Are you getting my point? So these overlapping with this, these overlapping with this, these overlapping with this. So like that again you can continue. N minus 1, m minus 1 is also there. See, there is one more same color I will have to show. So many overlapping sub problems. तो मतलब ये है कि अगर आप एक बार ये फार्मूला जहां पे भी कंप्यूट कर चुके, तो then you would have used it at different places. So therefore this tree proves that, this tree structure proves that LCS has overlapping sub problems. And LCS has optimal substructure property here, optimal substructure property. So therefore it clearly implies you can solve this problem using the principle of optimality dynamic programming. You can solve it with dynamic programming. तो आप कैसे सॉल्व करेंगे? सॉल्व करने के दो तरीके हैं. Either you can go with tabulation or you can go with recursion tree top down approach. एक टॉप डाउन अप्रोच से लेंगे, रिकर्शन ट्री एक शॉर्टकट मैं जो कहता हूं वो भी बताऊंगा और एक टैबुलर फॉर्म से भी बताऊंगा मैं. ठीक है, दो अप्रोचेस से दो प्रॉब्लम्स हम सॉल्व करेंगे ऑन LCS, और एक आपको होमवर्क भी दूंगा मैं, देन यू कैन वर्क आउट दैट होमवर्क एज वेल. ठीक है, तो आई विल टेक वन सिंपल डेटा सेट आई हैव. वो डेटा सेट में हम देखेंगे, आई विल टेक दिस डेटा सेट, जस्ट गिव मी अ सेकेंड. एक सिंपल डेटा सेट है, दैट्स व्हाई आई प्रिफर टू टेक दिस डेटा सेट. I'll take a new page. I want to find the LCS of the following. Please observe. LCS of, let's take the two strings as ABBA, ABBAB and ACBAB, ACBAB. चलिए, एक्चुअली ये प्रॉब्लम तो हम सॉल्व कर सकते हैं बाय टेकिंग आवर टैबुलेशन फॉर्म. ठीक है, टैबुलेशन फॉर्म से तो हम ऑलरेडी सॉल्व कर सकते हैं, लेकिन मैं ये चाहूंगा आप ये शॉर्टकट मेथड लर्न करें सो दैट इन द एग्जाम यू कैन अप्लाई इफ यू वांट दिस शॉर्टकट. जैसे मैंने मल्टी स्टेज ग्राफ के लिए शॉर्टकट अप्लाई किया था, उसी तरह आप इसके लिए भी आप अप्लाई कर सकते हो शॉर्टकट. कैसे करेंगे? प्लीज हैव अ लुक. सी ऑन बोर्ड. विदाउट टेबल, like in a top down fashion how we are working, please observe. The first point, case 1 applies, is it not? Case 1, B is matching with B. So by case 1 I would write like 1 plus LCS of, right? I will write the remaining part of the string A, B, B, A, and this as A, C, B, A. Is it right? Correct. फिर उसके बाद देखिए आप again case 1 apply. So when case 1 apply, I will write it like again 1 plus whatever is the length of common subsequence of A double B and ACB. ठीक है. Here again case 1 applies. B and B are matching. So therefore 1 plus whatever is the common subsequence of AB, AC. ठीक है, यहां तक क्लियर है. ठीक है, चलिए फिर उसके बाद B is not matching with C. So therefore I will have two cases now max. तो क्या होगा? LCS of, I will take the full string AB and here reduce by 1, or LCS of, I will reduce by 1 and take the full string here. ठीक है? ठीक है, इसके लिए again case 1, case 2. So this will take it like LCS of full string AB and null, and this I will take it like LCS of A and here also A. When I take up this apply, I mean boundary condition apply null character, so therefore this is 0, and this case 1 apply, so 1 plus LCS of null, which is 0, 0 plus 1, this is 1, and this is 0. So maximum of 0, 1, this value returned is 1, right? So this path is returning 1. When I come out for this, again case 2 apply, so therefore this is LCS of A reduced by 1 here A, or LCS of, here we are reducing, so it become null and this become AC. Hope I am doing correct, check it. कहीं भी अगर मिस्टेक हो रही है तो प्लीज बता दीजिए. तो यहां पर केस 1 अप्लाई होगा 1 प्लस LCS of null and null, इसका होगा वैल्यू 0, 0 plus 1, this return 1, right? And this returns 0. So this value is returning 0, this value is returning 1, maximum is 1, so therefore इसकी value 1 है. तो ये भी 1 है, ये भी 1 है, so therefore it is going to return 1 at this place. So 1 plus 1, therefore this is returning 2, 2 plus 1 is returning 3, 3 plus 1 is returning 4, आंसर हो गया आपका 4. That's all, this is a problem. आपको कोई टेबल फिलअप करने की जरूरत नहीं है. You can work in a top down fashion, in this way, solving this problem. Am I clear? और अगर आपको कैरेक्टर होना है, कौन से कैरेक्टर्स है, तो फॉर द लॉन्गेस्ट कॉमन सबसीक्वेंस यू कैन चेक दिस कैरेक्टर मैचिंग. सो यहां पर आप लिखोगे B, राइट? यहां पर कैरेक्टर मैचिंग है, यहां पर लिखोगे आप A, यहां पर लिखोगे B, राइट? यहां पर मैक्सिमम देखिए आप दोनों से भी 1 है, 1 1. So either you can take from here or you can take here. The character matching here is also A, here is also A. You can take any one, say let us say A. कोई भी दो पॉसिबिलिटी नहीं है, एक ही पॉसिबिलिटी है. तो therefore आपका कैरेक्टर बन गया, आपका सबसीक्वेंस हो गया A B A B. That's all. This is the answer for it. So this is the approach that you can follow in the exam if you are asking. But traditionally अगर आप tabulation process से देखेंगे, tabulation approach से देखेंगे, तो वो कैसे करोगे, right? Tabulation approach. So here I will take another example for tabulation approach. Kindly see on board. I want you to fill up this matrix right now in 2 to 3 minutes maximum. This is character X, M, Z, J, A, W, X, U. This is string Y, right? X, M, J, Y, A, U, Z. So how will you fill up this matrix? I am leaving this as an exercise for you right now. Fill up at least few entries, देखिए, my string is starting from here, please observe, my string is starting from indexing 1 going up to 7, indexing 1 going up to 7. So therefore this is 0, this is 0. That means after 1 it drops to 0, after 1 it drops to 0, after 1 it drops to 0. Come on. So this index is 0. तो पहले आप कौन सी रो फिल अप करोगे? फर्स्ट रो एंड फर्स्ट कॉलम इज 0, इज इट नॉट? String with null character in X, sorry, null character in Y, and null character and whatever number of characters in X. String Y with 0 characters and string X with any number of characters, length of common subsequence is 0 as per initial condition. If I is equal to 0, J is equal to 0, then it is 0. So therefore, first row and first column is 0. First row and first column is 0. Is it not? फिर उसके बाद चलिए, तो इनिशियलाइजेशन का स्टेप हो गया. नेक्स्ट क्या करेंगे हम, अब देखिए आप ये सेल की वैल्यू अगर आपको डिटरमिन करने हैं, दिस इज नथिंग बट string y having one character x and string x having one character m. So are they matching? They are not matching. They are not matching. Case 2 apply. Case 2 में हमने क्या कहा था, maximum of I minus 1. So I is 1, I minus 1 मतलब 0 and j is equal to 1 here. तो या तो ये सेल की वैल्यू होगी मैक्सिमम या ये सेल. So maximum of these two cell I have to take it here. So I can take this or I can take this. Maybe I take this from top. So I put an arrow to indicate that I have taken from here. I have taken from here. उसी तरह आप next value देखिए आप, x and z not matching, again 0 copied from top. x and j not matching, again 0 copied from top. Maximum of 0 comma 0, so 0, right? फिर उसके बाद आप देखिए यहां पे आ जाओगे, x and a not matching, this is also 0 copied from top. ठीक है, फिर उसके बाद x and w not matching, so therefore again copied from top. हाँ, अब यहां पर क्या हो रहा देखिए आप, x is matching with x. So case 1 apply. So by case 1 it is nothing but 1 plus, boys and girls be careful, 1 plus I minus 1 j minus 1. So I minus 1 मतलब ये रो हो गई, j minus 1 मतलब ये. So therefore this is the diagonal की entry होगी. तो मतलब 1 plus 0, whatever value I have here, 1 plus 0 is 1. This is copied from diagonal. 1 plus 0, 1 plus 0, 1. समझ गए बात? Then x matching with u, it is not a match, so therefore maximum of 0, 1, because x was already matched earlier. So maximum of 0, 1, तो आ जाएगा 1, हम ये ले है यहां से एंट्री. This is how I fill up. चलिए जल्दी जल्दी मुझे बताइए, फिलअप करिए मैट्रिक्स और मुझे फाइनली इसकी वैल्यू बताइए जो हमें बताएगा कि आंसर क्या है. What is the answer? What is the value? Come on, I believe. Just take not more than 2 minutes. Not more than 2 minutes. Even 1 minute में भी आप कर सकते हो अगर आपको प्रैक्टिस है. You can fill up this matrix very fast. Take maximum of column if there is a mismatch and diagonal में sum add कर दीजिए if you basically get the answer. Yeah, Satram B Nayak has already done. Shifu Qadir has already done. Very simple. Very simple. What will be the answer? Many people are saying so far, very happy about that. Very good. Other also, please work out. 4. Many people have said, so I will take it 4. और आपको आंसर अगर देखनी हो, मैं I have already have the answer here. Kindly check. This is my answer. So wherever there is a match, you can put that character which is matching. Like for example, x is a match here. Right here there is a match j, and like that you can put here there is a match j, like that. So this is how I can take the string what is common by showing this path. From this path, what is the common subsequence you can collect from here. You have taken this 4 from here, you have taken from 3. So you can travel along this path and collect the characters which is matching, and you can get the common subsequence. And in fact, you can trace all common subsequence from this matrix. You can trace all common subsequence once you get this matrix. So this is the tabulation process. So what is this called? This is called tabulation process. Tabulation process. चलिए ये बेसिस पर मैं आपको एक होमवर्क भी दूंगा. This is my homework for you. I mean, I've taken a realistic problem asked in some exam, right? Look at this. C of ij is equal to 0 if I is equal to 0 or j is equal to 0. Is equal to I greater than 0, j greater than 0, and x of I is equal to y of j. It is 1 plus ci minus 1, j minus 1. नहीं तो max of c of I minus 1 j, ci j minus 1, if I is greater than 0, j is greater than 0, and when x of I is not equal to y of I, you need to fill up this matrix. Please, boys and girls, take this as homework and work out as a matter of practice. I'm not going to do now. You can take it as a practice and do it as a homework. I mean, as a matter of practice, you can do it later on as homework. ठीक है? So this is common subsequence. अब आ जाएंगे इसके performance पर, मतलब time and space complexities के ऊपर, right? So let us talk about the performance. Time and space requirements of LCS. सबसे पहले हम बात करेंगे brute force. If I work out this problem using brute force, what will be the time and space complexity? If you work out the problem using brute force, I mean, in the exam you can go with, as I said, whichever method you feel like you are comfortable with, you can go with. I would prefer you go with shortcut method. जैसा मैंने multi-stage graph में भी आपको shortcut method बताया था, उसी तरह यहां पर भी आपको शॉर्टकट मेथड इन द फॉर्म ऑफ ट्री स्ट्रक्चर बताया हूं, यू कैन गो विद दैट. ओके, अगर उसमें आपको कोई डिफिकल्टी हो रही है तो देन यू कैन गो विद ट्रेडिशनल टैबुलेशन प्रोसेस, देयर इज नो हार्म, देयर इज नो वरी. चलिए, ब्रूट फोर्स. ब्रूट फोर्स में यू विल हैव टू डू व्हाट? यू विल हैव टू enumerate all possible subsequences, of either x and y, strings x and y, and compare them with other string. अगर मैं x के enumerate कर रहा हूं तो फिर कंपेयर करूंगा y से, या y के का enumerate कर रहा हूं तो कंपेयर करूंगा x से. So if I do like this, then I'm very sure the time complexity of this approach will become dash, order of dash. If I go with enumeration, the time complexity of brute force approach for LCS problem would become order of dash. Come on, boys and girls. क्या होगा time complexity if I go with enumeration? Enumerate all possible subsequences of either x or y, not and y, or y, and then compare it with other. Exponential value बताइए मुझे क्या कैसे होंगे. देखिए, first I will have to enumerate for x, for example, then it become order of 2 power n. 2 power n enumerations होंगे, and to compare each subsequence with the characters, I mean the length of y, so therefore I have to multiply with m, or it will be order of 2 power m into n. So therefore this become exponential time. Brute force approach will become exponential time. Then as a simple 1 mark question I am asking you, if you go with tabulation approach, dynamic programming, tabulation method which we have just now understood, which we have seen just now, tabulation method, can you tell me what will be the time complexity? What will be the time complexity? Come on. What will be the time complexity if I go with tabulation method, which we have listed out just now? String x having n characters and string y having m characters. So time complexity straight away become order of n into m. Space complexity requirement will be for the table, right? That table here, which I have shown you. This table. That size of the table is n cross m. n cross m. So space complexity will also become order of n into m. अगर आप इसे proof करना चाह रहे हो, we can write a simple algorithm here very fast. Algorithm LCS of x and y, where you can say x is having characters 1 to n and y is having characters 1 to m. I will take a table by name L having 1 to n plus 1 and 1 to m plus 1, because 0 is there for initialization. I can do it like this, right? So what will be my first step? I will write only for loop for I is equal to 1 to n, 0 to n. 0 भी है हमारे पास condition. For j is equal to 0 to n. Then what should I do? If I is equal to 0 or j is equal to 0, then what should I write? L of ij is equal to 0, is it not? Initialization condition, yes. Check at that, check that. I is equal to 0 or j is equal to 0, Lij is equal to 0, else if x of I is equal to y of j, that means when I come to else part, that means I is not 0, j is not 0. That is very clear, is it not? I will come to else part when both are false. When both are false. If both are false means I is greater than 0, j is greater than 0. Then I check if x of I is equal to y of j. Then what should I write? Simply I will write L of ij is equal to 1 plus L of I minus 1 comma j minus 1. Else x of I is not equal to y of j. So therefore what will I write? L of ij is equal to maximum of, I need comparison here, maximum of, right? L of I minus 1 comma j or L of I comma j minus 1. That's it. That's all is the concept. 2 nested loops. Only 2 for loops like this, going from 0 to n means n plus 1, and this is n plus 1. So if you take the order of it, will be naturally order of n into m. This is how we derive the algorithm for LCS in a very simple way. In a very simple way. ठीक है? चलिए, this is the time and space complexities of LCS problem. एक और problem before we close for the day, I will just describe to you. It is not there in the Karman textbook. That's why I would like to describe it. It's a new problem. It is called reliable system design. Let me see how many of you can answer this question. Reliable system design. And some people even call it as reliability design. Reliability design. It is a problem related to what we call designing of an n-state system. N-state system. I can describe it like this. Please see. We are having devices connected in series, something like this. This is device D1, device D2, device D3, so on, device Dn. They are connected in cascade. I am sure in the subject of digital electronics you might have studied what is the meaning of cascade design. So I will take an externally provided input, process in device D1 to generate the output. Output of device D1 will serve as input to device D2. Output of device D2 will serve as input to device D3, and like that it goes. This is what we call it as, an n-state system. This is called n-stage system. ये सिस्टम हो सकता है या तो इलेक्ट्रॉनिक्स का या हो सकता है फॉर एग्जांपल इलेक्ट्रिकल का. These are the different devices connected in series, cascade design. The device may be like sequential device or electronic device or electrical device. Every device is characterized by two parameters. Please see, cost and its reliability R1. Cost and its reliability R2. Cost and its reliability say R3, and like that the cost is Cn and device reliability Rn. What is reliability? Reliability means the probability of the device functioning properly. Reliability का मतलब है the probability of the device functioning of the device की functioning की reliability है, probability है. So therefore the value of Ri, reliability, always lie between 0 and 1. Probability की value हमेशा lie between 0 and 1. So that is the reliability. अब यहाँ पर दो चीजें मैं आपको पूछने जा रहा हूं. Then based on that I will ask my next question. What is the total cost of system? And what is the reliability of the system? Come on, boys and girls. आपने probability भी पढ़े होंगे आप लोग. So based on that, this problem is directly related to probability. अब बताइए, first, what is the total cost of the system and what is the total reliability of the system? Come on, tell me the answer. What is the overall cost? Cost तो बता दीजिए, बहुत simple है. Total cost of the system will be how much? What will be the total cost of the system? हाँ, यहां पर वही मिस्टेक करते हो जो आप कर रहे हो. कुशल यादव, यू आर सेइंग Cn. Cn is not the total cost. बच्चों यहां पर गौर कीजिए, C1, C2, C3 आर डिफरेंट वैल्यूज. Ci की वैल्यू सेम नहीं है. नो भगवादारी, प्लीज ऑब्जर्व. यही मिस्टेक करते हो आप लोग. इट इज नॉट n into Ci. It is not n into C. It is sigma, please. It is sigma. That is what I wanted to tell you. It is sigma Ci. Total cost. Total cost is sum of all Ci's. C1 plus C2 plus C3 plus Cn. चलिए ये देखेंगे. What is reliability of the system? अगर इसकी reliability R1 है, इसकी R2 है, इसकी R3 है, इसकी Rn है, then what is the overall reliability of the system? Come on. ओवरऑल टोटल रिलायबिलिटी कितनी होगी सिस्टम की? कमान कमान, ओवरऑल रिलायबिलिटी कितनी होगी सिस्टम की? कपिल अग्रवाल, यू आर राइट. P1 from no not n into RI, फिर वही गलती कर रहे हो. प्रोडक्ट ऑफ रिलायबिलिटी, एक्सेलेंट. प्रोडक्ट ऑफ रिलायबिलिटी I is equal to 1 to n. देखिए आप, अगर कोई एक डिवाइस फेल हो रही है तो पूरा सिस्टम फेल हो जाएगा. R1 into R2 into R3 into Rn, if any Ri becomes 0, whole system collapse, right? So therefore this is the cost. अब प्रॉब्लम यहां पर यह है डिजाइन में, अगर मान लीजिए कोई भी एक डिवाइस की रिलायबिलिटी बहुत कम हो और बाहर के सबके डिवाइसेस की रिलायबिलिटी अच्छी है, तो क्या होगा? जो भी डिवाइस की रिलायबिलिटी कम हो, दैट विल बिकम द बॉटलनेक फॉर द सिस्टम रिलायबिलिटी. सबकी 0.9 0.8 है, इसकी 0.2 है, सो दिस विल बिकम द हर्डल. तो हमें क्या चाहिए? हमें इंप्रूव करना चाहिए. वी हैव टू डिजाइन द सिस्टम इन सच अ वे दैट द ओवरऑल रिलायबिलिटी ऑफ द सिस्टम बिकम हाई. How to improve the reliability of the system? I am asking you the question, please answer. बताइए. How to improve the reliability of the system? Let me see. That is the crux of the problem. कैसे आप reliability of the overall reliability, total reliability of the system improve करोगे? कैसे करोगे? बताइए. Come on. What is the general principle that we follow for improving the reliability of the system? General principle हम क्या follow करेंगे? करते हैं. Not median. Yes, the general principle that we follow for improving the reliability of the system is by following the norm of replication concept. Duplication or replication? Duplication or replication? Duplication or replication. That is, instead of having one copy of the device, let there be having multiple copies of the device. Like for example, here I show. मान लीजिए in stage 1, instead of having one copy, we'll have multiple copies of the same device. Same device के multiple copies. Stage 2, instead of one copy, let us have multiple copies. Like that, last stage, we'll also have multiple copies of the same device. So this device D1, this device D1, this device D2, 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 DN, DN, DN. अब यहां पर एक इंटरेस्टिंग क्वेश्चन है. स्टेज 1, स्टेज 2, स्टेज N. एक इंटरेस्टिंग क्वेश्चन है. लेट मी सी अगेन, हु विल आंसर? हु विल आंसर? प्लीज ऑब्जर्व. देखिए आप, imagine for example there are m1 copies of device D1, where m1 is greater than or equal to 1 and less than some upper bound. 1 less than or equal to m2, less than or equal to upper bound. 1 less than or equal to mn, less than or equal to some upper bound. हमने क्या किया? हमने मल्टीपल कॉपीज इन्वेस्ट किया हर स्टेज में, रादर देन हैविंग वन कॉपी. क्यों? अगर कोई एक कॉपी अगर होती, तो अगर वो फेल हो जा रही कॉपी, तो होल सिस्टम इज कोलैप्सिंग. अब जब हमारे पास मल्टीपल कॉपीज होंगे, तो अगर कोई एक कॉपी फेल होगी, तो हम इमीडिएटली एक और बैकअप कॉपी ले लेंगे. तो मतलब रिलायबिलिटी इंप्रूव हो गई इस स्टेज की. So my dear students, the interesting question coming up here, if stage I has mi copies of device Di, right? Then my question is, please observe, if stage I has mi copies of device Di, या m1 copies है, या m2 copies है, या m3 copy है, minimum value of mi is 1 and maximum is sub upper bound. So if mi copies are there in stage I of device Di, then my first question to you, please answer, be ready and answer, what will total cost of the system become? What will total cost of the system? Come on, tell me. Total cost. Total cost कितना होगा system का? What will be the total cost of the system? That is what Kushal Yadav, again making a mistake. It is not sum of mi. Write it properly. सोचिए आप. Cost of stage 1 plus cost of stage 2 plus cost of stage 3 plus cost of stage n. The summation of what? Yes. So it is nothing but sigma Ci into mi. I going from 1 to n. Is it right? Is it right? उसी तरह, this is 2-mark question. Let me see who will answer. Who will answer? 2-mark question. What is the reliability of the system now? What will be the reliability of the system now? Can I say that the reliability, Bhagwadari, again you are wrong, sigma MICI, not just MICI, sigma. Reliability of the system will become, see, if I say reliability of stage 1, listen boys and girls, if I say reliability of stage 1 is given by a function pi 1 of m1, matlab pi is indicating the reliability of stage 1 having m1 copies of device D1, pi 2 of m2 represent reliability of stage 2 having m2 copies of device D, like that pi and mn. So therefore, the reliability of the system will become product of pi I mi, I is equal to 1 to n. Reliability to multiply karenge na, right? So product of pi 1 into m1 into pi 1 of m1 into pi 2 of m2 into pi 3 of m3, so on up to pi n mn. This is the reliability of system. This is a 2-mark question which I am asking you. Can anybody suggest to me what will be the formula for pi I mi? If you can tell me the answer, then I can certainly say that, say for sure with confidence that you are good in probability. What is the formula for pi I mi? 2-mark question, potential question, 4 options can be given. Come on, tell me. What will be the formula for pi I mi? What is pi I mi? Again I am telling you. Pi I mi represent the reliability of stage 1 having m1 copies. I mean, stage I having mi copies. So what is the formula for it? What will be the formula for it? Not mi by ri, not product of ri mi, no. Reliability of stage I having mi copies of device di. देखिए यहाँ पर m1 copies है, यहाँ पर m2 copies है, यहाँ पर mn copies है. हर device की individual reliability है r1, 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 r2, 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 rn, 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 इसी तरह. तो पहले आपको क्या करना होगा? पहले आपको reliability of failure मालूम करना होगा. When can I say the stage fail? Stage will fail when all copies fail. Please follow me. A stage will fail when all copies fail. Ri is the probability of device functioning properly. तो device की failure probability क्या होगी? Device की failure probability क्या होगी? Device की failure probability होगी 1 minus Ri. Success probability है Ri. Failure probability 1 minus Ri. तो 1 minus Ri become the failure probability for one copy of device. तो पूरे copies fail होना मतलब यह है 1 minus Ri into 1 minus Ri into 1 minus Ri for all mi copies. 1 minus Ri power mi. Power mi is the reliability of failure of the stage. All copies of the stage failing. This is the reliability of failure. Reliability of success क्या होगी? Reliability of success होगी 1 minus of this. So this is a formula for pi I mi. Now based on this formula, right? Based on this formula, we will, UI is some upper bound that you can find with some approach. I will just show you quickly before we close for the session. How are we going to derive a recursive formula based on optimality principle to solve this problem? How? So here I would say like this. Let Fn of C total cost be the reliability of n stage system with a total cost of C. That means जब भी हम प्रोजेक्ट डिजाइन करेंगे तो टोटल कॉस्ट शुड नेवर बी मोर देन सम गिवन कॉस्ट. प्रोजेक्ट कॉस्ट होगा, ये प्रोजेक्ट कॉस्ट है C. टोटल प्रोजेक्ट कॉस्ट इज C. Are you getting my point? Total project cost is C. Is like to be treated like knapsack. knapsack की कैपेसिटी होगी, इसी तरह प्रोजेक्ट की टोटल कॉस्ट होगी C. तो हमें डिसाइड ये करना है कि कितने कॉपीज हम स्टेज 1 में रखें, कितने कॉपी स्टेज 2 में रखें, कितने कॉपी स्टेज n में रखें, so that the reliability is maximum. Overall reliability of the system is maximum. So we want to maximize this reliability. So here I would write Fn of C is equal to max. कैसे करेंगे? Reliability of the last stage pi n into mn. This is the formula. अभी हमने derive किया. Reliability of the last stage, right? This is to be multiplied with, these are reliability of n stages, which is obtained by multiplying reliability of the last stage with reliability of remaining कितने स्टेजेस, n-1 स्टेजेस, सो देयरफॉर n-1 ऑफ, अब वो n-1 स्टेजेस के लिए कितना कॉस्ट बचेगा, टोटल कॉस्ट अवेलेबल विल बी c माइनस कॉस्ट ऑफ द लास्ट स्टेज, कॉस्ट ऑफ द लास्ट स्टेज इज गिवन बाय c and mn. This is a formula where I say mn lie between 1 and some upper bound un. This become my formula based on optimal substructure. देखिए आप optimal substructure, fn is computed in terms of n-1, n-1 in terms of n-2, n-2 in terms of n-3, like that it goes until you come to f1. f1 will be computed in terms of f0. f0 of any x, that means reliability of a system which is not having any stages. जब कोई system ना हो उसकी reliability 100% होगी, that means multiplicative identity will always be 1. So this become my formula based on optimal substructure property or satisfying optimal substructure property derived based on principle of optimality. Right? Whatever be the reliability of the remaining stages should be optimal. Then only my total reliability of the system will be considered. C and Mn. Cost, C and Mn is representing cost of last stage. Cost of last stage. तो ये cost आपको total cost में से subtract करेगा, for then only I will have the remaining cost for remaining n-1 stages. So this is reliability of n-1 stages. This is reliability of nth stage based on optimality structure. So this is the paradigm for solving problems based on this. So using some data, you can use this equation and get the result as we have done for the previous problems. Right? उसी तरह मैंने यहाँ पे कुछ questions, sample questions रखे हैं मेरी slide में. You can basically solve them, right? As a matter of exercise. कुछ questions मैं यहाँ immediately solve कर लूँगा, बाकी के आप solve कीजिएगा. Critical algorithm, matching pair. Sometime questions have been asked. Quick sort. Floyd-Warshall's algorithm. Floyd-Warshall's algorithm is dynamic programming. Quicksort is divide and conquer. Kruskal's algorithm for spanning tree, greedy method. So be prepared to work out questions like this on matching pair. Answer the questions for this. Let me see who will answer. Questions, direct questions like this you should be prepared for. What is the answer for this question, boys and girls? What is the answer for this question? Direct question, 1 mark question. There is a problem called sum of subsets. मैंने explain नहीं किया यहाँ पर, लेकिन because it is not there, so but you should be knowing it. You should be knowing it. लेकिन इसकी peculiar characteristic है जो मैं आपको बताना चाह रहा हूँ, please. Sum of subsets, यहाँ पर जो option दिया गया है यही बहुत important है. You can, yes, very good, Shifu Qadriya, that is correct. Sum of subsets का प्रॉब्लम जो है डेफिनेटली यू कैन सॉल्व विद डायनामिक प्रोग्रामिंग, लेकिन आप बैक ट्रैकिंग से भी सॉल्व कर सकते हो. बैक ट्रैकिंग से भी सॉल्व कर सकते हो, ये बहुत इंपॉर्टेंट है. So therefore, if this question would have been like an MSQ, then both option A and B would have been correct. Both option A and B would have been correct. So boys and girls, be careful with that. Sum of subsets can be solved using dynamic programming and backtracking. And also remember, there are some problems like traveling salesperson problem, TSP. इसी तरह traveling salesperson problem, please remember, can be solved using dynamic programming, can be solved using, for example, backtracking, and can also be solved using branch and bound. I think backtracking, no, this again is 0-1 knapsack. 0-1 knapsack. You can solve with dynamic programming, you can solve with backtracking, you can solve with branch and bound. तो इसी तरह मैं ये चाह रहा हूँ कि list of problems you try to make a sort of cheat notes or short notes, जहाँ पर आप पूरे problems कौन से problem कौन से strategy से solve हो सकते हो, ताकि इस तरीके के questions अगर आए तो आप immediately or honestly easily solve कर सकना, right? So make a list of that as a shortcut, as a preparatory short note. ये एक sum of subsets का है, आप बाद में इसे solve कर लीजिए. What is the equation for it? I am leaving it for you to work out. Okay. ये भी एक question है based on, this was also asked in one of the paper. As a homework, as an exercise, you can try solving this question also. इस तरीके से they can give. They give a string PA and a string B. Let x be the length of the longest common subsequence. X is the length of common subsequence between A and B, and let y be the number of such longest common subsequence. Both x is length of common subsequence and y is number of such subsequences. Then they ask what is the value of x plus 10y as a NAT question. So as a homework, please work out this and try to work out. So this is what I had in my plan for discussing with regard to dynamic programming in the crash mode, right? Other problems also you can prepare on same lines and try to work them on, right? And carry and do the practice. So next class we will take up the discussion on another topic which is not exactly like algorithm, but basically like some miscellaneous topics I call, which we generally name it as graph algorithms. ग्राफ के ऊपर, जहां पर मैं आपको ग्राफ थियरी नहीं पढ़ाऊंगा, जस्ट आई विल स्टार्ट विथ रिप्रेजेंटेशंस ऑफ ग्राफ्स लाइक एडजेसेंसी मैट्रिक्स, एडजेसेंसी लिस्ट, और हम कॉन्सेंट्रेट करेंगे ग्राफ टेक्निक्स के ऊपर, जहां पर मेरा डिस्कशन होगा डेप्थ फर्स्ट सर्च ऑन वेरी डिफरेंट टाइप्स ऑफ ग्राफ्स, डेप्थ फर्स्ट सर्च ऑन अनडायरेक्टेड कनेक्टेड ग्राफ्स, अनडायरेक्टेड डिस्कनेक्टेड ग्राफ्स, डायरेक्टेड कनेक्टेड ग्राफ्स, डायरेक्टेड असाइक्लिक ग्राफ्स, फिर टोपोलॉजिकल सॉर्ट, ब्रेडथ फर्स्ट सर्च, राइट, FIFO breadth first search, LIFO breadth first search, LC breadth first search, these varieties. And then if time permits, we will also look into some applications like connected components, strongly connected components like that. ठीक है, ये मेरा agenda होगा in the next class for graph based algorithms. चलिए आज के लिए इतना ही. Thank you very much. Good night. Take care.